Okay, so this is the beginning of chapter 4. This is one of our longer chapters in semester 2. So let's get started with 4-1. We're talking about angles and radian measure. A lot of this information will hopefully be review for you, but we want to make sure that everybody is on the same page and that you guys know what we're talking about with all of these different terms. Now this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. This is the coordinate plane. Okay, and this is our vertex here of this angle. We also call it the origin. And then we're going to be looking at angles. Now this will be the initial side of the angle. You'll hear that term a lot. And this will be the terminal side of an angle. Again, you'll hear that word a lot. And then we usually use the variable theta to represent this angle. Now, this should be a term you remember from geometry, but this is a ray. We have a point, and then it continues on in this direction. And let's go over some more vocabulary. So we can also talk about angles in standard position. This is standard position, starting on the positive x-axis and opening up counterclockwise. Okay, so again, vertex on the origin, initial side on the positive x-axis. Positive angles go counterclockwise from standard position, and negative angles go clockwise from standard position. So if I opened up this way, that would be a negative angle. We can also talk about types of angles. We have acute angles less than 90, right angles equal 90, obtuse angles are bigger than 90, and straight angles equal 180. And then the parts of a circle. So this is the center. These are our radii, or the radius here, from the center to the edge of the circle. And this would be called a central angle. Okay. Now we can also convert between degrees and radians. You should be familiar with both of those. And so if I'm going from degrees to radians, I'm going to use this formula. If I'm going from radians to degrees, I'm going to use this formula. And let's go ahead and do just a couple examples. So I have negative 135, so I have it in degrees, and I want to turn it into radians. So I'll multiply by pi over 180, and then I can reduce here, and this can become a 3 and this a 4, and we end up having negative 3 pi over 4. We can do the same thing. We can go from radians to degrees, and we multiply by the opposite, so 180 over pi. So our pi's cancel out, and our 180 and our 3 can reduce to 60, and we're left with 300 degrees. Now, as you move on in math, we will talk about degrees less and less, and we will talk about radians more frequently. Now there's some special angles that hopefully you already know, but we will review. If I'm looking at these black lines here first, we're starting at 0 degrees, and then we have 90 degrees, 180 degrees, and 270 degrees, and then back at 360 is back landing at the same spot as 0. Now we can also write these in terms of radians. So 0 radians, and pi over 2 for radians. This would be pi, and this would be 3 pi over 2, and then 360 would be 2 pi. Okay. Now let's go with the 45-degree angles. We're going to count by 45 degrees. So this is 0 plus another 45, then another 45 would be 90. Another 45 would be 135. Another 45 would be 180. Another 45 would be 215. Another 45 would be 270. Another 45, I'm sorry, not 215, 225. Another 45 would be 315. Okay. Now we can do the same thing with the radians. 0 And 45 degrees is pi over 4, so we can count by pi over 4. 0, pi over 4. Another pi over 4 would be 2 pi over 4, reduced 1 pi over 2. Another pi over 4 would be 3 pi over 4. Another pi over 4 would be 4 pi over 4, or just pi. Then 5 pi over 4. 6 pi over 4, which reduces to 3/2. And then 7 pi over 4, and then 8 pi over 4, which reduces to 2. You can also think about it in terms of counting by odd numbers. So 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. But the 45-degree angles are all over 4. Now, looking at these red angles here, these are our 30-degree angles. So it's 30 degrees here, 30 degrees here, 30 here, and 30 here. So this is 30 degrees. And 30 degrees less than 180 would be 150. 30 degrees more than 180 would be 210. And 30 degrees less than 360 would be 330. Now we can also notice some similarities with these angles in radians. This is pi over 6. And so if we're going up pi over 6, removing a pi over 6 from here would be 5 pi over 6. Adding a pi over 6 from here would be 7 pi over 6. And removing a pi over 6 from here would be 11 pi over 6. Again, the 30-degree angles are all over 6. And we'll notice in just a second that all the 60-degree angles are over 3. So we have 60, another 60 puts us at 120, another 60 puts us at 180, another 60 puts us at 240, another 60 puts us at 300, and another 60 back at 360. So this would be pi over 3, plus another pi over 3 would be 2 pi over 3. Another pi over 3 would be 3 pi over 3, which is just pi. And then 4 pi over 3, 5 pi over 3, and 6 pi over 3, which gets us back at 2 pi. Okay, so notice they all have the bottom of 3 for all the 60-degree angles, and then it goes 1, 2, skips 3, and 4, 5. Okay, so you're going to need to have that memorized, so go ahead and get started working on memorizing that. Let's go ahead and flip the page. And now we can talk about a special type of relationship between angles. Two angles can be coterminal if they have the same initial side and same terminal side. So for example, if I have the angle 45 degrees, that's this angle right here. But if I have another angle that ends at that same spot and starts at that same spot, let's say we'll go all the way around to 360 plus another 45, so that would be 405 degrees. Those are coterminal, same start and same end. Okay. Now we can add or subtract 2 pi or 360 as many times as we want from an angle to get a coterminal angle. So let's practice this a little bit. It says find a positive coterminal angle less than 360 or 2 pi. Now right now we have 17 pi over 3. That's way more than 2 pi. So what I can do here is subtract 2 pi as many times as I want. Now I need a common denominator here. So what I really want to do is 17 pi over 3 minus 6 pi over 3. This is still 2 pi here. And that'll give me 11 pi over 3. But this is still more than 2 pi. 11 divided by 3 is 3 and a little bit more than that. So we know that this is too big still. So we can subtract again to see if that will give us something that we're looking for. And that will give me 5 pi over 3. And that is something less than 2 pi like it asked for. And so that's our answer. Now, if you wanted to subtract by 12 pi right away, you could, but it has to be a multiple of 2 pi. not of just pi. You can't subtract by 3 pi. Looking at the next one, we can do this with degrees as well. Now, I can add 360, but this is negative 855. I'm going to need to add 360 a few times. So 360 times 2 is 720. That's not going to be big enough to make this a positive coterminal angle. So let's try 360 times 3, and that's 1080. If we add 1080 to this, we're going to get 225. And that is a positive coterminal angle that's less than 360. Now there's one last thing to look at in this section, and that's going to be arc length. So if I have a circle here, and I know my radius, and I know my angle in here, then I can find the length S of this arc. So this length right here. Okay. Now if I give you this length right here, and I tell you what the radius is, you can also find the central angle. So you can use this equation to find the missing pieces. And that is the end of section 1.